Welcome back, dear students, in the online session of chemistry. Here I am explaining chapter number 2, part 3. In this session, we'll complete the covalent bonds and their types. So let's get started. How can we define a covalent bond? By the way, in simple words, it's the bond formed between atoms by the sharing of electrons. Now, the next question that pops up in our mind is how many electrons need to be shared to form a covalent bond? Is it one electron or a pair or more than a pair? Can you guess? Let me help you with the answer. When we say sharing, it means that both the atoms need to contribute for the bond formation, right? It indicates that each atom will give at least one electron from its valence shell. Does that tell us that a covalent bond will involve minimum of one pair of electrons? Yes, a covalent bond needs at least two electrons or simply one pair of electrons. Such a type of covalent bond where one pair of electrons is shared between the atoms is called a single covalent bond, and it is denoted by drawing a single line between the two atoms. A simple example that explains this type is the formation of a chlorine molecule. How do you think this molecule was formed? We know that chlorine has 7 electrons in its outermost shell. That means only one electron is needed by it to complete the octet. Now, here's another chlorine atom which again has 7 electrons in its outermost shell. Both of them want one electron each, and that is why we find two chlorine atoms coming together and forming a bond by sharing one electron pair. Now, if we look at this orbit individually, it has 8 electrons and this orbit too has 8 electrons. Stability achieved for the chlorine molecules. This was an example of a single covalent bond. So, do all atoms form covalent bonds by sharing a single pair of electrons? Think for a moment. We know that oxygen is in the diatomic state. That means one oxygen atom forms a bond with other oxygen atom to form a stable molecule. Do you know how many electrons are shared in this bond? What do you notice? There are 4 electrons shared. That means both the oxygen atoms contribute 2 electrons each, thus giving 2 pairs of electrons in the bond formation. So, is this not an example of covalent bond? Well, it is. But covalent bond has one pair of electrons being shared, right? Don't forget, it is a minimum of one pair that's needed for formation of the covalent bond. That means this case is also an example of a covalent bond. Such a covalent bond which involves 2 pairs of electrons getting shared is called a double covalent bond. It is represented by 2 lines written between the 2 atoms, just like this as seen in case of oxygen. Now, on the similar lines, can you give me an example where more than 2 pairs of electrons are shared between the atoms? Wait a second. Are we trying to say that a triple covalent bond also exists between the atoms? Absolutely. And the best example to study this is the case of nitrogen. We always find a nitrogen molecule written like this. Needless to say that the 2 nitrogen atoms share a triple covalent bond. That means 3 pairs of electrons, or simply 6 electrons, are shared between the atoms. This helps both the atoms attain the stable state. Now, tell me one thing. Which type of covalent interaction does carbon prefer? Does it opt for a single or a double or a triple covalent bond? Astonishingly, carbon has the ability to form all these types of covalent bonds with different elements. Yes, can't have any of these covalent bonds with atoms of other elements or even with other carbon atoms. Types of covalent bond: polar covalent bond, non-polar covalent bond. Polar and non-polar covalent compounds. In a non-polar covalent bond, the shared electrons are attracted by the 2 combining atoms equally. But in polar covalent bond, the shared pair of electrons is attracted unequally by the combining atoms. In polar covalent bond, the combining atoms have different electronegativities. Consider the formation of a covalent bond between two atoms by the sharing of electrons. Then there is the possibility of one atom having more ability to attract electrons than the other. For example, in the case of hydrogen chloride, chlorine attracts the shared electron pair more. Here, the shared pair of electrons is more towards chlorine. This is because chlorine has more ability to attract electrons. This ability to pull shared pair of electrons towards itself is known as electronegativity. Non-polar covalent bonds. A covalent bond having equal distribution of shared pair of electrons between the combining atoms is called a non-polar covalent bond. A non-polar covalent bond is formed between atoms of same type. They have same electronegativity. Hydrogen, chlorine, oxygen, nitrogen, fluorine, etc. are examples of non-polar covalent bonds. In chlorine molecule, the shared pair of electrons is distributed equally, so the chlorine molecule is non-polar in nature. Polar covalent bond. A covalent bond having unequal distribution of shared pair of electrons between the combining atoms is called a polar covalent bond. Due to the unequal distribution, one end of the molecule becomes slightly positive and the other end becomes slightly negative. A polar covalent bond is formed between two different types of atoms, that is, atoms having different electronegativity. The arrow represents the shifting of electron pair towards chlorine. In the case of hydrogen chloride, chlorine is more electronegative compared to hydrogen. So the shared pair of electron is shifted more towards chlorine than hydrogen. Thus, the chlorine end gets a negative charge due to the increased electron density. At the same time, the hydrogen end gets a slight positive charge. This can be represented as follows. The slight positive and negative charges on the polar covalent bond give it a small ionic character. The polar covalent bonds are intermediate between ionic bonds and pure covalent. Now we have reached to the end of the video. In the next part of the video, we'll complete the chapter number 2. Till then, take care, be safe and study well.